Welcome back, everybody. We're gonna do some more with the vectors. We covered vectors and it's what they are. Now we're gonna look at like an algebraic approach to looking at them. We said vectors can start, they can be in anywhere, as long as they're the same length and pointing in the same direction, it's the same vector. But oftentimes when we're doing stuff with them, we want them to start at the origin. So a vector that starts at the origin. I'll say if, since I started writing it that way. The vector starts at the origin. Which is 0, 0 on the graph, in case you forgot that. We call it a position vector. If the, let's say the endpoint is at AB. Or terminal point, I believe was the, for some reason, deviant fucking word they use rather than just endpoint. Is at A comma B. We write the position vector as. We use the arrow brackets, the pointing brackets. That way, it's clear it's a vector, not just a point.
Let's see.
So some vector u. When you get to Calc 3, assuming you're going down the engineering branch. You'll have vectors that do an X, Y, Z. A third dimensional component. But that's later. We don't do 3D here. Sick or allergies?
Maybe both.
Oh, sucks. Cause that's like, get the fuck over. Fucking infect me. So, pictorially, what are we talking about here? Got a point here at AB. And my U vector. That's U. It's still too bright. We want to talk about the length of U. How could we get it from our picture? What?
Make a triangle, right?
Yeah. We make a triangle. Okay, so that length's A, that length's B, what's the length of U?
Is the. Or is the formula, right?
A squared plus B squared equals.
We're doing like an A squared plus B squared equal, I assume you mean this one, huh?
Yeah.
But when we have a U, so like C would be the square root of A squared plus B squared. Let's say the length is C. The way they tend to write the length of U, some folks just do a single vertical bar around them. And others do, which I prefer the double vertical bar. This is called the magnitude of the vector.
Was that like the absolute value?
That's why I like the double bar, because the vertical one looks like absolute value, and that's not what it is. It is this,
It's magnitude.
it is definitely, it's a length thing. So, I'll make a little note about that. I use the double bars. Because the single bar looks like absolute value and it is not. It most definitely it is not. So we have magnitude of u equals the square root of a squared plus b squared in that picture. If you use some coordinate x naught, y naught. X naught squared plus y naught squared. Wrong, Lewis. Yeah, it's not, it's like a zero, it's just like the starting point. Often it's done because when you're looking at something, a lot of times we're doing vectors or stuff like that as stuff goes over time. Holy shit. What the fuck, you got your hair changed, I like it. You can see, I can see your face,
Only 10 minutes in the class.
you're way over there, I look like you try to hide off camera. Out of Dave's perception. So like when you're like doing following like a path of something and using it as a vector. We use the zero to represent when you start down the path, times zero. That's generally where the x zero and y zero comes in. What about this angle?
It's tan.
It's still tangent, that hasn't changed. Tangent theta is y over x, in this case, b over a, if we use a and b. Alright. Let me give you guys one to try. Find the magnitude and direction. U equals. -5, 4. Feel free to talk to your neighbors while you work on it, we'll do it in like a minute. You don't have to be silent. Fine, okay, that's the years where you start to go, fuck, I really should start acting like an adult. Yeah,
That's so true.
21, you're like, I'm not ready to give that shit up, I was still like acting fucking juvenile.
Yep.
I haven't figured it out in 25 years, I was 50 over spring break and I still act juvenile. Still play video games, I still do stupid shit. Act responsibly financially, that's the important part. Take care of your bills, take care of your family, and anything else. Stay the end kid.
Oh, yeah. When you say direction,
Like what's theta?
oh, okay.
Let's change that, direction, angle. One more minute, then we'll start working together. Alright. What should I do here to find the magnitude?
Just take the square root of -5 squared plus 4 squared.
What do I get?
Square root of 40.
Yep. It's important to note that is positive 25, not negative 25. I see even Calc 3 students fucking still fucking that up. It's a goddamn tragedy. Does it get any more cleaner than that? Not really. Square root of 36 would be 6. Square root of 49 would be 7. This is closer to 6 than 7. I'm guessing about 6.4. But I didn't put it in a calculator.
He's 6.4.
That's a handy skill to like develop, like probably going, how close am I to the perfect squares? That way you don't, like, how often do you really need an exact decimal? If I need to know it's around 6.5. I can figure that out doing that without having to pull out a calculator, because you don't wanna pull out your phone and do some fucking math on it. But if you know your basic squares. Alright, the next problem, they're gonna want us to do the hard way, but we're not gonna do the hard way, we're gonna reason out how to do this easier. So, next example. Is a ship leaves port. Oh, I didn't do the direction angle, did I? So we would have tangent theta equals. Y over x, which would be 4 over -5. So theta is gonna equal tangent inverse of that. That's actually an exact answer, if we want to get like a degrees, which is more reasonable. Make sure you're in degrees mode. Tangent inverse. Theta is about -38.7 degrees. Does that seem reasonable?
That's fine.
1, 2, 3, 4, 5.
-5.
I went the wrong way. No, that isn't reasonable. -5, 4 is over here. So what is -38.7 actually telling us?
Angle.
The reference angle. It's coming from there. There's no way that's 38.7 degrees. So. I'm gonna say 180 plus that. And we'll be at 141.3 degrees. It's always handy to sketch out where it is on a grid, so does this angle make sense? Alright, a ship leaves port on a bearing. 25 degrees. And travels 61.4 kilometers. The ship then turns due east. We'll say travels due east. 84.6 kilometers. How far is it from port? Now, and at what bearing? What?
It's 8.4.
Yeah, section 8.4. Draw the picture they gave us. That's port. That's due north. 25 degrees means in that direction. It's gone 61.4 kilometers. And then from there, it goes due east. 84.6 kilometers. And, oh shit, that didn't end up straight, there we go. And we wanna know. This is like our U. What's the magnitude of U and direction angle? And they, you're gonna love this, they gave us in the picture. That this is 115 degrees right here. Which implies. We have a side angle side, they're wanting us to probably use law of cosines, fuck all that. Cause like in the next page, they're gonna, like right after this, they go over like the real like easy way to do it. If we treat this as a position vector. And where our first point is A, and we end up at point B over here. Wouldn't it be just easier to like figure out, find the position vector of A? And then move to B? Algebraically? Yeah, so we're gonna have to work with some sort of triangle. That's 25 degrees. Which means, I like doing where we have that. I'm gonna say that's 65 degrees, because we know this adds up to 90. And now it lines up a little bit better with. We have this is 61.4. That's my Y value, that's my X value. We could have done this just the same with 21.25 down here. That's gonna be your X value, that's your Y value. And 61.4 kilometers, both will work. I hate thinking of the triangle, this one, I don't like that one. Cause it looks weird reading Y and X like that, I don't know about you guys, maybe I'm just neurotic. How could I find X here?
Have two angles and a side, right?
I technically do, that would make this angle up here 25 degrees.
You don't find a cosine.
You're working too hard. It works, but log cosine simplifies way the hell down. This is a right triangle. SOHCAHTOA. So we're looking at x is adjacent to the 65, adjacent, and we have the hypotenuse. Adjacent and the hypotenuse is cosine. Cosine of 65 degrees equals adjacent over hypotenuse. And that means sine is the opposite one, sine of 65 degrees is gonna equal y over 61.4. Kilometers times cosine of 61.65. Y equals 61.4 kilometers times sine of 65. Figure out what those are. In 25.9. Here. And 55.6 here. What are the units here? What? It's when you started in kilometers, we should still be in kilometers. Is that what you want me to do?
Yeah.
How would I write, so this is at point A. How do I write the vector to point A? .9 comma 55.6. Now, point B is due east, straight east. What value is changing here?
X.
X is changing. So if we were to think about like where the points end up. This point right here is at 25.9. Comma 55.6. And we know the length of this is 84.6. The only thing that's changing is the x, so we should be adding the 84.6 to the x, right? So what is 25.9 plus 84.6?
110.5.
110.5?
That's like,
So B should be at 110.5 kilometers, and the y value hasn't changed. 55.6 kilometers. This shows us something. We did it like algebraically, we using the points on the graph, but if you add, if vector. If U is AB. And V is CD. U plus V. We just add the x components. Because this vector from A to B, if I did it at the origin. The 84.6 vector. That vector there is 84.6 comma 0. It's got no y change. It's just in the x. And what we did is we added the x components and we effectively added the y components, but one of them was 0. A plus C, B plus D. So you just add the like terms, basically. X's add to x's, y's add to y's. Now they wanted, that's not what they wanted though, we found where it's at, but what do they really wanna know? They wanna know how far away and at what angle. So we can find the magnitude of B by doing what?
The square root of 110.5 and 55.6.
Square root of that, I am getting. Magnitude B. Is approximately 123.7 kilometers. That's 110.5, this is 55.6. We can find that angle. By doing tangent theta equals y over x. It equals tangent inverse of that. .73. That is not how they would say it though. If we go back to their original picture, they did bearing is off of true north. So we want to kind of do bearing off of true north also. North is this direction, so we kind of want this angle. That's the angle. I'll put a star in it, that's the one we want. How do we get that?
90 minus 26.7.
Yeah, these two, this is a 90-degree angle, so if I subtract 26.7 from 90. What? Funny, well. That's how I got the 65 earlier when I was doing this, but we're now at a new angle, it's like that, we don't. No, always gonna report it off of true north though, it's not gonna be off the last angle, that's a good question. 63.3 degrees. So it's off true north. Bearing of 63.3. 123.7 kilometers. Now, we could have done this with the law of cosines. And verified it that way, but that was gonna be the law last time. A lot more work. So like this pulled out some information for us, and I'm gonna give you some algebraic properties of the vectors before we do the next one. Assuming u equals AB. And B equals CD. If I do u plus v, you're just adding the x components. What do you think happens if I subtract? You're gonna subtract the x components. If I multiply u by some constant k. That's k times a comma b. What this ends up doing is it ends up becoming Ka and Kb. And multiplies each of them. You're basically scaling up the triangle kind of thing. Ready for more? We'll do some examples with that. Real quick before we move on. Let's say u is the vector 6 comma -3. And v is the vector -14 comma 8. Find u plus v. Find 1/2 v. And then find 5u plus 2v.
Did after this or no?
Yeah, we do predictables.
Bodies and capping.
For Steve, we go play the same rule as KU,
Yeah,
yeah?
we're combining KU and then U plus V.
Oh,
This is the shit I can get behind, dude. Algebra. Present formula is easy. Start giving me fucking. I mean, I know this is trick, but I don't know, it's just different.
I bet a lot of people in here are like, fuck you, algebra, very easy. You'd be surprised how many people fail calculus because their algebra sucks. Yeah. Oh, it's a lot. There's a lot of algebra in the calculus. A lot of the calculus stuff is really actually not that hard. But the algebra tends to get intense.
That's what my last professor said, that he's like, as things get more advanced, a lot of times the mistakes are just simple. It's like algebra mistakes.
Right, but they keep like, you end up doing a lot of algebra, so it keeps compounding.
And then one little thing,
Yeah, now there are mistakes, common mistakes in calculus that show up all the time. Students all the time fuck up the product rule and the chain rule, you're not in calculus that, you'll see. When you get there, they fuck up the chain rule all the time. It's all the time. They, or when there's a chain rule and a product rule, they fucking mix them and do them all at once and they make, it's fucking atrocious. They just fucking get it and like. If they still manage, you can fuck those up and still pass with a C. Quite easy, cause it's just one set of two topics in all of them. But the fucking chain rule and the product rule just keep up coming, Calc 2, Calc 3. Every fucking, it's an ongoing thing and it just keeps compounding, stacked out with the algebra errors. It's just, yeah. I just got finished the Calc grading, the Calc 3 tests. Last night. Yeah, I'm still working on you guys, I started them today, but they're not done. And like most of them that fucked it up were fucking up Calc 1 or algebra stuff. Or they did, the Calc 3 stuff they didn't get, the problem was just blank. Which makes it really, I love it when you guys fucking do blank problems, makes it really easy to grade, I can go through a fucking blank test, like, fuck. 0 points, 0 points, 0 points. And I don't feel bad about it either. I used to feel bad. I'm not the one that didn't do my homework. I did all my homework, I fucking did more than my homework so that I'd be ready. Alright, what do we do what do we get when we do this? We're adding the x components. And we're adding the y components. So what is the resulting vector?
-8.
Pictorially. 6 -14 is like down here. And let's see, next. What the fuck? Let's try that again. 6 -3. Is down there. And we're adding -14. 8, which is up here. And when we add the vectors, we're ending up with -8, 5, kind of like that. This, well, if I drew it from the scale, this would look better. The drawing's not good, never mind. If you draw it to scale, look, you can see like one is like completely overriding the other, it's a lot longer. Alright, what about 1/2 V?
Got -7.4, just taking half of each value.
Should be doing 1/2 of each value. Which is gonna give you -7.4. What is 5u?
30, -15.
You multiply each of those by 5, you're gonna get 30 and -15. What's 2v?
-28, 16.
-28, 16. And if you stack them like this, addition's really easy, you just add vertically. 5u plus 2v is 2, 1. One more, let's take a break, let's take a 10-minute break. Pause this video. Alright, we're gonna continue from where we were. What the hell? Grab my fucking stack upside down again. That's an old fucking form. So a vector that has a magnitude of 1. Is called a unit vector. And like vector u, we had vector u. When you do a unit vector,
That's a pleasure.
a lot of times for the unit vector, they do this. They put a little hat on it. That's how they distinguish a unit vector from a regular vector. When you see the little hat on it. Hat indicates unit. Vector, which is the length of 1. This leads to two of the most common ones. Go on the x-axis and the y-axis. If I go right exactly 1 unit, we know this has a length of 1. It's only going one direction is 1. This vector is 1, 0. They call this I. That's my I. Letter I, but lowercase. I always put a little curve on it because otherwise it looks like a 1. And a unit vector going up 1. That would be 0, 1. That's what they call that vector. J. I, J. In 3D, the third one is K hat. IJK. Not often use letters in algebra, that's why. So leads us to another form of writing a vector u. Vector u equals AB. Can be written as A I hat plus B J hat. Why? AI is A times 10, which is A0. And by the same thing for, wish I hadn't wrote that shows those others, but I don't wanna say it out loud now. That sound wrong. You're gonna have 0 comma B. Or B in the J hat direction, there we go, that's cleaner. So when I add these two, AI and B in the J hat, you get A comma B. I don't know why they like the I and the J, okay. It does tend to end up being handy if you're gonna like become like a mathematician. And you go down the dark hole of like doing pure math. But like the vector form usually works just as well. And in my opinion, takes up less space, it's easier to read. There's another way of writing the unit vector, or not the unit, well, any vector, U. Another option. From my vector U. Theta. And the length of this is the magnitude of U. So using SOHCAHTOA. Cosine of theta is A over the magnitude of U. Which means A equals the magnitude of U cosine theta. And I knew sine theta is B over the magnitude of U. And if we clear fractions, we get B equals the magnitude of U times sine theta. And that's the same AB that we have up there. So I can write U as magnitude of U cosine theta. Magnitude of U sine theta. This is actually a handy form because when the same constant's in both of them, we can factor it out. This is that K thing we had, the KU vector we had. I can write this as the magnitude of U times cosine theta sine theta. Why is that a handy form? Take a look at it. Ignoring the magnitude of U, what's this magnitude? Square root of cosine, yeah, look at that shit,
Shit. So this is 1.
which is 1, which means that's a unit vector. Always. And then it's scaled up, scaled to the right length. I'm gonna say correct length. By multiplying by that magnitude of U. Kinda neat. Let's do some examples of this. Cause what we were doing is we were taking the vector and breaking it down into like the X and the Y. But we were drawing a picture and doing like toe and all that. If you just memorize this magnitude times cosine theta or sine theta, you get there really quick. Those some examples. Let's say U has a magnitude of 14.5. And the direction angle of 220 degrees. Right position, or right position vector. I like the Lord Heavy trading card. I like the Lord of the Professor. It's so close to Lord Vader. My champion.
You didn't wanna be doctor.
Well, I'm not a doctor, so like calling me Dr. Jones is wrong. Although that has the Indiana ring to it. Which is what kept me pursuing a doctoral degree for a lot longer than I needed to. Finally said, fuck that, I really wanted to go by Dr. Jones. Indiana Jones. Well. That's the magnitude of U. So we're gonna do U is. Magnitude of U 14.5 times cosine of 220. 14.5 times sine of 220. And if you're ever going like, I don't know if that's right, you can always. Sketch a picture real quick. What quadrant is 220 in? Third. This would be 180, so I need to go like another 40 degrees. This would be 220 degrees. So over here, X and Y should both be negative. And since it's 40 degrees, the X should be bigger than Y. Larger number. Let's say the absolute value of X is bigger than Y. So that, and it's close to the 45 degree, at 45 degrees, they're gonna have the same. Same thing, cause remember you do like. It's square root 2 in that first quadrant. So like, when they're the same length or that, but other than that, one gets bigger and one gets smaller. Like, they're close together, that's close to the 40 degrees, that seems right. Now that we've worked on one together, let me give you a couple of them to crash through real quick. Let's do magnitude equals 8. Theta equals 135. Magnitude of 4. Theta equals 270. And let's do another one with magnitude 10. Theta is 340. Back to your unit circle. What is 135 degrees? What's the point there? That's negative root 2, right? That's that if I change from parentheses to vector. Cause it's a position vector now. You can just use, if it's one of the angles you already have pre-memorized, you can just use that shape. This one is gonna be 8 times that. Square root 2/2, 2/2. The 8 will cancel out the 2, you're gonna get negative 4√2, 4√2. That's an exact answer. If you need like a decimal value, you can always throw it in a calculator. Or under 6. Doing it that way should make problem number 2 a lot quicker,
Yeah, super easy.
not having to throw the shit in a calculator. What point is 270? 0, -1, normally. On the unit one, so we'll scale, yeah, well, we're gonna scale that up by the 4 and get 0, -4. I don't have one for 340 doing. This is, now you're stuck, you gotta type into that shit. I strongly recommend, if you recognize the angle, don't go to your calculator. Do, not at first at least, do it with the unit circle knowledge that you have. Write it out, at least especially while you're doing homework. Write it out with that, then verify with the calculator. This will reinforce the unit circle knowledge that you learned, and actually, it's just. The better that's reading, like, in reinforcing your memory. It's gonna save you so much time if you're doing shit, that like calculators really slow you down. Unless you need them, they slow you down on basic arithmetic.
You got a point where you already don't use the calculator?
For this, oftentimes the stuff I teach, yeah. I pick stuff, like problems are set up to be at least semi-nice. Even if they're not, like this is an ugly number than decimal, it's an exact one with the square root, and exact is always better. Because you can always throw it in a calculator and round to the decimal place you need. So like if you rounded to 1 decimal place and you need 3 decimal places, you just stop. I avoid using the calculator as often as I can. I will write out the fractions, do the math and fractions, even with ugly fractions. Because I'm less likely to fuck it up than I am to fucking fat finger my calculator and hit the wrong goddamn button and not know it. You're fucking trying to type in a string, a long ass thing where it's longer than what you can put on the calculator. You can't see what you had on the, like, the beginning anymore, I can't like quickly look to see that I typed it in right. So I gotta hit the arrow back thing, it's so much slower to actually. For anything that I don't need it on, like this I need it on, and this one we need, I don't know about the cosine 340. So we're gonna have 10 times cosine of 340. 10 times sine of 340,
Let's see.
who did that? I mean, this problem. Not the sneeze, I don't know.
I was like.
Everyone's-
That's the way that sounded, my bad. Who's worked this out already? What is it?
9 point, I just did 4 decimal places, so 9.3969 for the X. And then for the Y, negative 3.4202.
Did anyone else here go 4 decimal places? Really? I'm surprised, I figured most people were gonna be like, oh, I'm gonna do 1 place, maybe 2. As many as you wanna do, it's fine, I'm not judging.
Significant digit after both of those was a 0, so I was like, oh. Let's see.
Alright, oh, there was 0 after that.
Yeah, that's why I was like, oh, good spot.
Alright, so we did addition and subtraction of vectors. Right? Did vector u plus v. We did u minus v. What about multiplication? It turns out there are, we're only gonna do one in this class, but there are 2 forms of vector multiplication. We write one of them with a dot between it, and we write the other one with an X between it. This one is called the dot product. Product is the result of multiplication, so that's why it's called dot product. This one is called cross product. And you'll see it in Calc 3 or maybe physics first, I don't know. Calc 3 and physics. It's a 3D idea. They are 2 different things. The dot product results, the result is just a number. And they call that a scalar. So if I say the word scalar, I'm referring to like a number. The cross product results in a vector. So it produces a third vector. You start off with 2 vectors, you multiply them, and you get a third vector. We're only gonna do dot product here. If U is AB and V is CD, then, and it's often said, they don't say, some people will say the dot product of this and this. They often read it as U dot B. They don't say U dot product B, they just say U dot B. You multiply the X components. And you multiply the Y components. Which is handy, it's kind of like exactly what we did with addition and subtraction, we added the X components. Added the Y components or subtracted. the multiplying looks the same here for the dot product, which is nice, it's not changing the strategy up. So A B dot C D. Equals A dot C, B dot D, but when it's not in a vector form anymore, the dot is just regular multiplication. Dot still means multiplication, that's why we got rid of, stop using X. I wish they didn't teach like. Elementary students to use like an X for multiplication. Cause they know. Like algebra is not like, you can learn algebra in like junior high. You can start taking it then, if you're an advanced student, you start doing algebra in junior high. You start doing, using X as a letter, not a fucking multiplication sign, relatively early.
Get them ready for that level.
Yeah, get it ready for it right at the
I
beginning,
don't know, that's.
fucking stupid.
Yeah.
I think they don't wanna confuse them with the decimal point versus the multiplying. And they figure by the time you're using X for a variable, you're older and you should be able to get a grasp of it. I'm guessing, I think that's their reasoning, I don't know. Alright, let me give you guys some examples, give you something to do. Oh my god, I said this was a scalar and then I wrote a vector. That's completely fucking wrong. It is AC and BD, it's AC plus BD. Fucking amateur hour. I even made sure to point out it's just a number and then I fucking write the vector. Get it in my head and. So that's the slight difference in how it is with addition, subtraction. Addition, subtraction vectors, you still end up with a vector. Here, we don't end up with a vector. But it's still x times x and y times y. I still get fucking calculus 3 students, some of them leave shit like this. Kinda like this one, like, dude, no, you're losing points, for fucking being a dumbass. At this point, you should fucking be cleaning that shit up. That's meaningless. Like, I have to stop and think about what that is. What is -5 times -2? 10. 2 and -4? 8, 10 minus 8 is 2. Start doing that grayscope, and I can't use my really stamp anymore, and if I don't want my really stamp. I might stop using the fucking grayscope. This also feels slower. It actually feels slower to grade on that fucking thing. I gotta type in the fucking things rather than write real fast. What about this one?
It's -10, so 0.
10 times 1 plus -1 times 10. 10 plus -10 is 0. It turns out a dot product of 0 is really nice, as we're about to talk about. there is a geometric interpretation of the dot product. How does it apply to our angles and shit we've been doing? U dotted with V. Is the same thing as the magnitude of U. Magnitude of V. Times cosine of the angle between them. When I teach Calc 3, you learn how to derive this, it's not that hard. You use the law of cosines, of course. Law of cosines has a cosine in it.
Look, it shows a fraction, it shows
I'm gonna do that next. Cause this one, like, shows the dot product alone. The fraction that Victor's talking about is if I solve for cosine theta. Cosine theta is U dot D over magnitude of U. Magnitude of D. This is a just as handy form, if not handier. This form might be used even more. So. Why does Hepe love a dot product of 0? The book talks about it, and this is. We definitely do it in Calc 3 when we do more vector stuff, but
says
orthogonal, it does talk about it, okay, good. That says if I plug it in up there, I've got cosine theta. Equals 0 over magnitude of U, magnitude of V. And at this point, I don't give a fuck what the magnitude of U or V is. That's 0. So what angle is theta? What's cosine, what cosine gives 0? 90 degrees. Which means. It makes a right angle, no matter what. Doesn't matter what orientation, which way they're pointing or anything like that. If the dot product is 0. Sometimes it's hard to tell. You could sketch two vectors and you go, that looks like it's gonna be 90 degrees. But it might be like 89.5 fucking degrees and but if you do the dot product and you get 0, you know it's a right angle. We tend to go, like when we did lines, they're called perpendicular. When we do vectors, they use the word orthogonal. No. That's the phonetic. No, that's how it sounds. Phonetic, orthogonal. Why did they change from using the word perpendicular? I don't know. The hell?
I was like, I tipped out a fist bump and then a handshake, and we both
Yeah,
agreed,
wow.
so.
Then it looked like you started tickling each other's fucking hand. I'm like, what the fuck, he's just throwing away a can, he's not waving, what is going on here?
I dap him up, dude.
I'm judging your guys' relationship. Fucking-
Secret handshake. Oh, shit.
Alright. So, a couple more examples. Find the angle between. mu equals 5, -12. And B is gonna be 4, 3. And we'll do another one with U is 4, -3. And B is 6, 8. This is gonna be cosine theta of 5 times 4 plus -12 times 3. And then over the magnitude of U and the magnitude of V. I don't know what those are yet. Squared plus -12 squared. 144 and 125 is 169, which is 13. So U is 13 in length. 4, 3 is a 3, 4, 5 triangle. I know that's 5. That's my U magnitude. V magnitude. 4 squared plus 3 squared. Square root of 25 is 5. So I've got 20 minus 36, I've got -16 over 65. If I do that calculator. Oh, that's. I wrote it wrong, yeah. The wrong goddamn number of the calculator. Cool. And then I do cosine inverse. I get theta equals 104.25 degrees. You work out the magnitude on this one, you're gonna get 5. Magnitude of B is 10. We've got cosine theta of 4 times 6 plus -3 times 8 over 5 times 10. So theta equals 90 degrees. That's really like the only one you're gonna recognize when it's a decimal. You're not gonna, you're unlikely to recognize square root of 2 over 2 or square root of 3 over 2 or any of those other ones. Unless you happen to have them memorized. I think one of them is 0.707. 0.88586 something, I don't know. I've seen them enough, I know 707 is the root 2 over 2. Alright, some properties of dot product, and then we'll be done. U dot V. If you work it out, looks the same thing as V dot U. Which is handy, it follows normal multiplication. 2 times 3 is the same thing as 3 times 2, it doesn't matter what order I multiply them in. Cross product does matter. Dot product does. If I have U and I dot it with V plus W. The multiplication distributes. Like it does with numbers, but now it's the dot product multiplication. Probably enough, I don't know why they do this, but they show doing U plus V. And then dotting it with W. Equals U dot W.
Bless you.
Plus V dot W. You got a lot of bless yous, you just got the big fuck you every time you sneeze. A couple bless yous, but the whole fucking class I get it, that's rough. This kind of like combines the first two. Number 3 is just changing the order of the multiplication and using the distributive property. K times the U vector, then dotted with V. Is the same thing as doing K times U dot V. And it's also the same thing as doing U times K dot V. Or KV. U dotted with KV. This going this way tends to be the more handy one. Like you can have some big ass numbers like 100 and 200. Just factor out the 100, then do the dot product with a 1 and a 2, and your multiplication gets a lot easier. So being able to like effectively, we can factor out the K. Making multiplication easier. Making the dot product easier. Two more rules. The 0 vector dotted with the U vector. When we do basic multiplication, what's 0 times anything?
0.
0. Same thing here. 0 vector dotted with the U vector is still 0. Not a vector, again. And there's one more. But I'm gonna work it out with you guys and show you where it comes from. Cause it's kind of handy to see where this one comes from. U dot U. Let's say U is AB. So when I do U dot U. I have AB dot AB. It's me A squared plus B squared. Well, what's the magnitude of U?
Square root of A squared
It's the
plus B
square
squared.
root of that. Which means U dot U. If I square both sides here. I get that. U dot U is equal to the magnitude of U squared. That you are free to get. I will see you guys on Thursday. Thursday sounds good.